Hi and welcome back. So in this video we're just going to keep going with our examples where we're trying to figure out the electronic geometry, the molecular geometry, the ideal bond angle, and the actual bond angle. So anyway, let's just get started with another example. So in this example we are going to be dealing with the molecule of CS2. So we are going to have carbon, which is going to be right here. And carbon is going to have 4 valence electrons. And then we're also going to be dealing with sulfur, which is right here on our periodic table, right under oxygen. And sulfur is going to have 6 valence electrons. So what is going to be our central atom here? Well, it's going to be carbon, right? So carbon is going to, carbon, I guess you could say it's the less electronegative atom. It's most often going to be our central atom, and it's also going to be able to form the most bonds. So carbon is going to be our central atom. And then we're going to have our sulfur atoms on either side, because carbon is going to be on the middle. And what kind of bonds are we going to form? Well, we're going to form double bonds with our sulfur. So this is going to our geometry for this molecule. It's going to be very similar to the geometry for carbon dioxide, right? Because sulfur has got the same valence electron configuration as oxygen. And we all, hopefully you've seen what the structure is for carbon dioxide, but it would look like this, right? So we would have a double bond with our oxygen. We would have 2 lone pairs of electrons around each oxygen on either side. And so each oxygen is going to have an octet of electrons because we've got 2 bonds and 2 lone pairs. And then the carbon is also going to have an octet because we've got 4 bonds around the carbon. And there's also going to be, and what's the formal charge going to be on each of these atoms? And the formal charge is all going to be 0, right? So, and this oxygen was right here on the periodic table, and sulfur is right below it. So it's going to have the same valence electron configuration. So we're just going to have 2 lone pairs on each sulfur atom. That gives us 2 lone pairs and 2 bonds, which gives us a full octet on each sulfur. We've got 6 electrons around each sulfur, so we have a formal charge of 0. And we've got an octet on our carbon atom, and we also have got 4 electrons around the carbon atom, so that gives us a formal charge of 0 for this structure as well. And so now, what is our bond angle going to be? What's this angle? And it's going to be 180 degrees, right? Because, actually I should have done this first, but what is our electronic geometry? So what is the electronic geometry? It's going to be linear, right? Because we've really only got 2 bonding we've got 2 bonding groups, and we don't have any lone pairs. So our electronic geometry is going to be linear. And then what is our molecular geometry going to be? Molecular geometry is also going to be linear. Because we have got no lone pairs on this carbon, no lone pairs that are going to be pushing our sulfur down or pushing our sulfur in any other direction, so the molecular geometry is also going to be linear. And so therefore, the ideal angle is going to be 180 degrees. And then also, because we don't have any lone pairs on this carbon, what's the actual bond angle going to be that we can expect? Well, it's also going to be, so the actual angle is also going to be 180 degrees, because we're not going to have any other electron groups pushing this angle one way or another. It's already our ideal angle is going to be what we actually observe. So our actual angle is also going to be 180 degrees. So anyway, hopefully that video helps. I'm just gonna keep keep doing more final review examples in the next few videos. So thanks for watching.